We're going to study real quick binomial probability. And binomial probability just means that there's two possible outcomes. I like to think of like true or false or right or wrong. Those are all possible outcomes. Basically, something will work or something won't work, and that's how binomial probability works. And so there's some interesting things that happen. We're going to look at is, let's say you had, I'm just going to give a quick example. Let's say you have a multiple choice test, and there's 4 choices, and we'll say A, B, C, D, and there's 10 questions on the test. Well, if you want to find the probability of getting 100 on the test, you know the probability of getting 1 right is 1 out of 4, but you have to raise that to the 10th power. And that's going to be an outrageously large number. So, actually, I'm not even sure what that is. Let's say 0.25 to the 10th. It's an extremely small. It's 9.53 or 9.4 times 10 to the negative 7. So it's going to be really, really hard to get 100. And now if I knew that I needed to get let's say a 60 on this test, I need to get 6 right. What's the probability of getting exactly 6? So what you have to do is you have to use this formula. It's kind of a crazy formula. It's NCR times P to the R times Q to the N minus R. Now remember, N equals the number of choices, or number of the total number of questions. R equals how many we want right. P equals the probability of it being right. Good thing I'm a math teacher and not an English teacher. Wait, nope, I am right. Ah, that's funny. That's even funnier. Alright. And then R equals the probability of being wrong. And I think I just messed myself up because I was thinking of right and wrong and I was thinking of WRIT. Alright, so I have 10 questions. I'm going to choose 6 of them because I want a 60. Well, I want to get exactly a 60. The probability of getting a question right is 1/4. The probability, oh, I'm sorry, that's supposed to be Q. How many? We want 6. That's going to be 3 out of 4. And that's going to be to the 4th because it's really going to be 10 minus 6. So when I do 10 choose 6, I get 210 times 1 to the 6 is 1 over 4 to the 6, which is some huge number. Then I get 3 to the 4th over 4 to the 4th. And let's see. So 210 times 1 times 3 to the 4th gives me 17,010. And then, like I said, 4 to the 10th gives me that a huge number. And I know this is going to be 4 to the 6th, 10th, because it's 4 to the 6th times 4 to the 4th. And I get 1,048,576. And if you divide that, you end up with 0.016222. And that's it. That's how you do it. So, I would like to turn that into a fraction. Unfortunately, I don't actually have my other calculator, which helps me do that. So I'm going to give another quick example. I'm going to erase this one, so if you need to pause and copy it down, that would be a good time. Let's give another example. And let's say I'm going to roll a die. Alright? I'm going to roll a die, and I'm going to roll a die 3 times. And I want to get exactly exactly one time I want to get a 5. Alright? So how many times am I rolling the die? 3. What's the probability of how many times do I want it to actually happen? Is 1. The probability of getting a 5 is 1 out of 6. And the probability of not getting a 5 is 5 out of 6. So once again, it's going to be NCR, N choose R, P to the R times Q to the N minus R, which gives me 3 choose 1 times 1 6 to the 1, because I only want that once, times 5 6, I want to fail 3 minus 1 times, which is twice. So when I do this, 3 choose 1 is 3, times 1 to the first is 1, times 5 squared is 25, over, that's going to be 6, 6 to the first is 6, and 6 squared is 36, which equals 75 out of, and I think that's 216. I'm fairly certain that's correct. Yeah, 216. 75 out of 216. And that can be reduced to 25 over 72, and that's it. So the probability of rolling a 1 5 out of 3 rolls is 25 out of 72. I'm going to give you one last example. Well, maybe I won't give you another example. But like I said, the key thing is the formula. NCR times the probability of a success times the probability of a failure raised to the R and the N minus R times, respectively.